All right, so this is lesson 6, continuing on with unit 7, solutions, solubility guidelines for aqueous solutions. Objectives, you're going to learn how to use table F to determine what substances are soluble or insoluble, meaning can they dissolve or not dissolve. And you'll also use the table F to help you determine whether or not a precipitate will form when two ionic solutions, okay, remember that's aqueous, in the aqueous state, are mixed and undergo a double replacement reaction. Oh, do we remember these types of reactions? So I have two guests here with me today, and it's Miss T and Miss E. Okay, mystery people, we'll figure that out. But here's a double replacement reaction. If you guys remember, we have two compounds to form two new compounds. What's happening here is the silver, the positive ion, is going to pair up with the negative ion of the other reactant, okay, to form the new product, silver chloride. And then we have this positive ion, and in order to determine which one the positive ion is, it's going to be the first one that is in the compound, because it's always the positive and the negative when we write the formulas out. So the positive is going to go with the negative ion over here. That's a polyatomic ion, so we have potassium nitrate. Okay, and we're going to learn in this lesson quickly how we determine which one's going to be the solid and then which still stays in the aqueous state. Okay, and that's this part right here. So table F will tell us what is going to be the solid that is formed. Okay, that is what is not going to dissolve. So solubility, table F, tells you what substances are soluble or insoluble. What do I mean by that? What can you tell me, Miss T? What do I mean by whether it's soluble or insoluble?
If it will dissolve or not.
Okay, if it will dissolve or not. Perfect. So it's used to predict whether or not a precipitate will form when two ionic solutions are mixed and will undergo a double replacement reaction. Now, this is key here, okay, because if there is no double replacement reaction occurring, then you cannot even use the solubility table F, okay? So a precipitate, now I explained this in class, a precipitate would be some sort of crystal that is formed, okay, when you have a supersaturated solution. But in this case, we're mixing two solutions together. So a precipitate in this sense, okay, in this aspect, is going to be an insoluble product that falls to the bottom of a mixture or a solution following a double replacement reaction. Okay, so this is very important. All right, we could see stuff at the bottom and think that it's saturated at that point. Yes, it is. It's not considered a precipitate. But if we have performed a double replacement reaction by mixing two solutions together and see something fall to the bottom, then it is considered the precipitate. Okay, little confusing. But a precipitate will form, or a visible reaction will occur if one or both of the products listed is insoluble. That is the precipitate. Now, let's look at table F, and it's tiny on here. What I'd like you to do is take out your reference tables, ladies, okay? And we're going to go to table F, and you're going to look at these and basically label on your reference table, you can do this, where it says exceptions, we're going to write insoluble on the left-hand side. So we're going to label that column 2. And then if we go over to column 4 here, where it says exceptions, we're going to put soluble, and I'm going to explain that in a minute. Okay, so how do we use this table? We find one of the ions in your chemical formula in either column 1 or 3. Okay, so here or here. Now, take note, all right, that there are only 2 positive ions that are listed in table F. So it's more likely that you're going to find the second ion, or the ion in the back, okay, or the ion to the right-hand side of the formula, versus the one that is in the front. Okay, so let's just double check. We have one positive ion here, and then these positive ions. That's it. Everything else is negative. Okay, so you might want to look for the negative ones first. So check if there are any exceptions to that ion. So you'll glance over to column 2 or 4 once you've found your first ion, and see if there are any exceptions. If there are no exceptions, you'll scroll up either column 1 or column 3, wherever your ion is located, to figure out if it is soluble or insoluble. Okay? Now, if there are exceptions to that ion listed in either column 2 or 4, then you read the exception and then you scroll up to the top and say, okay, well, it's the opposite. So if it should have been soluble, now there's an exception that makes it insoluble. Okay, and then same thing with anything from column 3 going into the exceptions for column 4. Okay, it's going to be the opposite. It'll make it soluble then. So then the best way to do this is to do some practice. Okay. All right, number 1. So number 1, Miss T is going to help us do this, and she's going to tell us how to do this. Using table F, we have to figure out if this is going to be a soluble or insoluble product. So what are we going to do?
First, look at the ion in the back.
Okay, which would be this, right?
Yes.
NO3. Where do we find that?
On the soluble side.
Okay, so we find that in column 1, right? The first column.
And it says it is soluble, so it has no exceptions, meaning it is still soluble.
Okay, so nitrate ion is found in the soluble compound column, which is the first column. If you look, there are no exceptions, therefore it has to be soluble. Doesn't matter what it's paired with. When there are no exceptions, we take it right from that column. Okay, number 2, Miss E. We have calcium carbonate here. What am I going to do first?
Well, if you notice that there is a negative ion, you look towards the back.
Okay.
And we notice that is a carbonate.
Okay.
And carbonates are in the insoluble group. Now, since it is paired with calcium, calcium is not part of group 1 metals, so therefore it is insoluble.
Okay, very good. It remains under column 3, as she should say, because it doesn't fall into the exceptions category. Okay, number 3, back to Miss T. We've got magnesium sulfate. Which ion am I going to look for?
Sulfate.
Okay, sulfate, the back ion right there. Okay.
Sulfate is on the soluble side. It is paired with magnesium. We look at our exceptions, and it doesn't say anything about magnesium, so it is still soluble.
Very good. Soluble. Okay, and 4, ammonium hydroxide.
Well, when we look at column 1, we see that ammonium is with the solubles as well. And then we look over to the OH, or hydroxide, which is in column 3, which states that it's insoluble. However, if you look at the exceptions, it says that if it was paired with an ammonium, it makes it soluble. So therefore, it is soluble.
Right. Also, Miss E, I want to add to that soluble, okay, that when you look at the positive ion, if you look that up in column 1, okay, the ammonium ion, there are no exceptions. So you actually don't have to look at the next one. Because if there are no exceptions, then we're just going to say it's soluble. Okay? All right, so that concludes our lesson. Thank you, ladies. You may say goodbye.
Goodbye, everybody.